This is bidirectional DC to DC converter. In this, the battery will be charged at one stage, and in next stage battery will be discharging. So it is termed as bidirectional DC to DC converter. Here this transformer will provide the main supply, that is 12 volt 3 amps supply it will be provided, and it is provided to this rectifier. The rectifier output will be the supply 1, and this battery will be supply 2. Okay, when main supply is available, battery will be charging. At the same time we will get output voltage. Okay, when the main supply is not available, battery will be providing the supply here, and this part is the converter part. Okay, this is the converter, and here this is for modes of operation. Okay, and this is the driver circuit part. Arduino will generate the pulses according to the mode of operation, and that pulses will be provided to this buffer IC. Okay, the buffer IC will provide isolation, and from buffer IC to driver IC the pulses will be provided. When the pulse is high, the supply connected across the driver IC will be connected across gate and source terminals of the MOSFET. So MOSFET will be on. When the pulse is low, this supply will be cut off, so there will be 0 volt. That means MOSFET will be off. Okay, this is the working of this driver circuit, and for driver circuit we need 12 volt supply, that we will take it from the this adapter, 12 volt adapter, and this adapter is for Arduino supply. This is the DC to DC converter for electric vehicle setup. Here instead of motor we are using one resistive load to check the working of this converter part. This converter consists of two sources. One is battery, next one is AC voltage source, that we can use it as any other renewable sources. PV, like that, any source we can use it. Here this is the main inductor, single inductor used in this converter part, and this is the main switch, okay, using for boosting that voltage from input voltage to load voltage, and also it is used to control the load voltage. Others and all, when battery is connected, what is the switching operation? When source is connected, what is the switching operation? For that purpose, other switches will be used here. Now we will turn on the controller. Next we will turn on the driver circuit supply. After that we connect the battery. Now we are connecting the battery. So here this is the load voltage. It is coming around 60 volt, it is coming, and battery voltage, it is around 12 volt. Battery voltage is around 12 volt now. Battery is discharging. Now we will connect the mains, that is one more supply. So here the load voltage is now, it is around 70 volt. We are getting load voltage is around 71.2 volt, and load voltage to battery voltage is 14.4 volt. That means battery is charging now. Battery is charging. So this converter, it can either charge the battery, and when the supply is not available, it can provide the battery can provide the supply to the load. Initially supply 1, when supply 1 is available, it can provide the supply to the load, and also it can charge the battery. When supply 1 is not available, at the time battery can provide the supply to the load. We will get continuous supply. So here the battery will act as a load at one time, and it will act as a source when the main supply is not available. That is the working of this converter. Useful for electric vehicle applications, and also it can be applied for UPS also. In UPS also we can use this converter.